Awesome. Hey, everyone. A very good evening. Thank you for joining us tonight. As I mentioned earlier, I'm the guest speaker for tonight, and I'm going to talk about Azure Logic Apps. And just a level setting here, it's roughly going to take an hour for me to cover my slides and demos that I have prepared. I would encourage you to keep this meeting interactive, and if you have any questions, feel free to unmute yourself and ask me. There is no moderator for today's meeting. So if you have anything, please feel free to unmute yourself and ask me. If you would like to post a question or comment on chat window, that also works for me. I have chat window opened up here in on my third monitor. So if you have anything, I can respond back there as well. And if you don't have any question or comment, I would encourage you to stay on mute to avoid any distractions. With that, let's get started. A quick introduction about myself. My name is Vaibhav Gujral. I have over 15 years of experience. Born and brought up in India, moved to Omaha in 2016. I currently work at Kivet Corporation as a cloud architect. I'm a Microsoft Azure MVP and a Microsoft certified trainer. Uh, Apart from regular speaker at different user groups and conferences, I do run this very user group as well, where we do conduct bi-weekly meetings. If you haven't checked out our website, do check out omahaazure.org. Last but not the least, I have earned several certifications in Azure, ranging from solution architect to DevOps engineer and so on. If you need any help, any guidance in earning your certification, feel free to send me a note. I will be more than happy to help you out with that. And I will be sharing my contact information towards the end of the presentation if you would intend to connect with me later. With that, let's get started with the presentation and let's see what we are going to cover today. In the next 60 minutes or so, we will see what logic apps are. We'll talk through the different components that a logic app is made of. We'll talk about connectors, triggers, actions, and control flows. We'll then talk about the different hosting options that are available for hosting your logic apps, like standard consumption and ISEs, like integration service environments. We'll compare each of those hosting options with each other. Then we'll also see how to create logic apps in Azure Portal, Visual Studio 2019, and Visual Studio Code. We will, if time permits, we'll also see how to set up deployments for logic apps. And last but not the least, we'll also look into different business continuity and disaster recovery options for logic apps. I have prepared a few demos to cover different concepts as we proceed. So if you have not used logic apps in the past, or if you have, regardless, I hope you will find this session useful. It would also be helpful if you are preparing for any Azure role-based certification, especially the architect one or the developer one. Starting with the very basic, for the benefit of people who might not be aware of what a logic app is, an Azure Logic App is a serverless offering from Microsoft, which is part of Azure Integration Services. It is essentially an integration platform as a service, which you can use to schedule, automate, orchestrate tasks, business processes, and workflows. When I say serverless, I mean you can run your logic apps in a consumption plan where you are only charged for your executions. If you have no executions, you don't owe a single penny to Microsoft. We'll talk about consumption plan and other hosting options in one of the later slides. You can design and build scalable solutions for different scenarios using logic apps like application integration, system integration, B2B scenarios, and so on. Some of the common examples you can use logic apps for could be order processing, where you might like to process and route orders from one system to another. Or you can use logic apps to send email notifications whenever specific event happens. You can use logic apps to perform an action every time someone sends you an email, or someone sends you a new tweet, or someone uploads a new file in your OneDrive or Blob storage. The possibilities are immense where you could leverage logic apps. All this is made possible by a number of built-in and managed connectors that are offered for offered for Logic App. You name a service that you want to integrate with Logic App, and chances are there would be a built-in connector, a managed connector for that. For example, for Logic Apps, there are connectors available for Office 365, Outlook, Azure Functions, Azure Storage, Azure Service Bus, BizTalk, Oracle, SAP, Salesforce, and so on. And just in case if you cannot find a built-in or a managed connector for the service you are trying to integrate with, you can either connect to the service using HTTP, or you can also create your own custom connector. We'll talk about connectors in detail in one of the later slides. So let's look into how logic apps are composed of. If you look at logic apps have four main components. When you create a logic app, you basically define an activity which is formed of a trigger and actions. And as the name suggests, you need a trigger to start the execution of a logic app. And within an execution, what needs to happen is defined in an action. Now, Logic App supports 400 plus. The last time when I checked, the list was 400 plus built-in and managed connectors, which allow you to integrate your Logic apps with different services. Each of these connectors come with their own set of triggers and actions. For example, there is an Outlook connector which has a trigger whenever for a new email arrival. It triggers a Logic app every time you receive a new email, and it supports multiple actions like reading and sending emails, reading attachments, and so on. Lastly, as I said, Logic app defines an activity, and the activity is formed of triggers and actions, and you can use control flows like if, for each, until, and so on to define your activity workflow built on top of those triggers and actions. To summarize, connectors help you quickly access the data, events, and other resources from other services and systems. You can use connectors to build workflows that use processes and integrate information across cloud-based or on-premises systems or hybrid systems. Now, each connector comes with its set of own triggers and actions that you can use in your Logic app workflow. Each trigger and action comes with its own properties that you can configure to make your workflow run. You can use control flows to define your workflows built on top of those triggers and actions. As I said in the last slide as well, there are around 400 plus connectors supported the last time I checked. And to integrate your workflow with a service that doesn't have a connector, you can either call that particular service over HTTP, or if it offers a REST API. Otherwise, you can also create a custom connector. Speaking of triggers, a trigger specifies the event that starts the workflow and is always the first step in any workflow. Each trigger also follows a specific firing pattern that controls how the trigger monitors in response to events. Essentially, in a nutshell, there are two different kinds of triggers that you can have for your Logic app: polling triggers and push triggers. Polling triggers regularly check for a specific service or a system on a specific schedule to see if there is new data available or if there is a new specific event that has taken place. And whenever new data is available or a specific event happens on that specific service you are trying to integrate with, these triggers create and run a new instance of your Logic app workflow. This new instance can then use the data that is passed from that service as input. An example of polling trigger could be Recurrence Trigger, which runs every time, or it could be a service bus trigger. The other type of trigger is push trigger, which listens for new data or for an event to happen without polling the external service. So whenever new data is available or whenever a specific event happens, these triggers create and run a new instance of your workflow. For example, an example could be HTTP request trigger. We'll see all different kinds of triggers shortly. For example, now if you might want to build a workflow that does something when a file is uploaded to your FTP server. As the first step in your workflow, you can use the FTP trigger named when a file is added or modified, which follows the polling pattern. You can then specify a schedule to regularly check for the upload events. Our trigger also passes along any inputs and other required data into your workflow, which can be referenced and used inside your workflow in different actions. For example, if you want to use Office 365 Outlook trigger for whenever a new email arrives in your mailbox to trigger your Logic app workflow, You can configure this trigger to pass along all the content from your email into the Logic App workflow through the trigger. And then your workflow can then process that information by using different other actions. I did touch about that there are around 400 plus built-in connectors and managed connectors. And I wanted to touch base again on that front. There are two different types of built-in connectors that we have. Built-in connectors and managed connectors. Built-in connectors essentially run natively on the Logic Apps runtime. The difference between built-in and managed connectors, if you have to understand, is that when you use a built-in connector, they don't rely on an explicit connection object type or explicit connection resource type, which is a different resource type in Azure. Whereas when you use managed connectors, they require an explicit connector object. And as I was saying, built-in connectors run natively on the Logic Apps runtime, whereas managed connectors are deployed, hosted, and managed by Microsoft. Those connectors provide triggers and actions for cloud services, on-prem and systems, or both. Managed connectors have 4 different categories of connectors that can be grouped into managed connectors, starting with on-prem connectors, which are used to access data and resources from your on-premises systems. Enterprise connectors help you connect to your enterprise systems like SAP. Integration account connectors help you implement business-to-business communication scenarios, B2B scenarios. And integration service environment connectors, or ISE connectors, are managed connectors which are only available for ISEs, which is one of the hosting option available for Logic Apps, under which you can run your Logic Apps in isolated environments. Starting with the built-in connectors, as you can see on this slide, there are numerous built-in connectors that you can utilize inside your Logic App workflows. These built-in connectors lets you control your workflow, schedule and structure, run your own code, or manage or manipulate data. What I'm showing on the screen is, if you will pick up some of the examples like the schedule trigger, it lets you run your Logic App on a specific schedule ranging from basic to complex recurrences. You can just, when I say basic, you can just run it on every 1 minute or every 10 minutes, but you can make it more complex. You can also provide values like what time zone it should run in, and so on. You can use request trigger to make your Logic App callable from other applications and services. You can use batch trigger to process your batch connector to process your messages in batches. You can use Azure Functions connector to call Azure Functions from your Logic App workflow that can run any custom code snippet from your Logic App. Likewise, you can also connect to different other Azure services, ranging from app services to API management. You can also use Azure Logic Apps connector from within your Logic App to call other Logic Apps within your workflow. On top of some of those built-in connectors, some of the standard connectors that you can use to automate your workflows within Logic Apps include Azure Service Bus, SQL Server, Office 365 Outlook, Azure Blob Storage, SFTP. Pretty straightforward, as the name suggests. Some of these can be used to integrate with different external systems. For example, there is one connector for Twitter through which you can connect to your Twitter account and manage your tweets, followers, timeline, and so on. You can connect to Salesforce, you can connect to FTP servers, you can connect to Dynamics 365, and so on. Here are some of the commonly used connectors for on-premises connectivity. Be aware that be aware that when you are using any of these on-premises connector, before you can use these in your Logic App, you first have to download and install an agent on on-premises server, which is known as on-premises data gateway. That gateway essentially provides a communication channel between your on-prem infrastructure to Azure. and that helps in establishing connectivity, and your logic app on-prem connectors can connect to on-premises systems. Some of the most common ones include BizTalk Server Connector, IBM DB2, MySQL, Oracle, Teradata, SQL Server, SAP, and so on. If you are an enterprise customer, you have been using enterprise systems, Logic App does support a few enterprise connectors ranging from IBM 3270 to SAP. Now, all the connectors we have talked about, they help us in connecting to different services and get the data and implement our workflows. But apart from that, we also need certain built-in control connectors that we can use to control the Logic App workflows. Essentially, these control workflow connectors help us in structuring and controlling the actions in our workflow. Pretty straightforward. It starts with condition, which is similar to an if condition, where we can evaluate a condition and execute the underlying actions based on the result of the evaluation. We can utilize for each to perform the same action on every item in an array. We can use switch to group actions into cases and execute it whenever there is a match found. We can use terminate to terminate the execution of a running Logic App workflow. And until is similar to for each, we can repeat actions until a specified condition is true. On top of control workflow connectors, when we implement Logic App workflows, I was mentioning all these connectors and triggers help us consuming input information from different services. So we certainly need to perform different operations on the incoming data and information from these services. So there are certain data manipulation connectors that we can utilize to perform operations on data. Starting with the data operations one, using those connectors, we can perform different category of operations on data, like we can create CSV table, we can create CSV data inside our workflow. We can parse JSON. We can join multiple string in an array. We can filter different arrays. We can create HTML table within one of the actions in data operations. Likewise, other data we also have specific connectors to perform operations with date time data. Like for some of the common examples are, we can add to time, like add 1 day or add 1 week or add 1 year. We can convert time zones from one time zone to another. We can get the current time through date time of connectors. Likewise, the last most importantly, we can also define variables using variable connectors in Logic Apps. We can initialize those variables. We can set value to those variables and use within the other actions to perform different operations on those variables. So that's pretty much about the connectors. Now let's talk about the different hosting options for Logic Apps. And before we talk about the different hosting options for Logic Apps, I think it is also important to understand the difference between a stateful and a stateless workflow. If you are creating a stateful workflow, you can essentially keep the data from the previous events. Those workflows save the inputs and outputs for each action and their states in an external storage, like a storage account, which makes reviewing the past history possible after each time a run is finished. Whereas in stateless workflows, you don't need to save, review, or review the data from the previous events. The stateless workflows, unlike the stateful ones, save the inputs and outputs for each action in the workflow in memory, and they don't transfer that into an external storage. As a result, the stateless workflows are typically very short, have very short run. They typically don't last more than a couple of minutes or so. That makes stateless workflows to be faster and of better performance over the stateful ones. So Here are the three different hosting options that are available for Azure Logic Apps. If you have been using Azure Logic Apps in the past, it all started with the consumption hosting plan where it was a multi-tenant option where uh, different tenants can run their Logic Apps in the same environment. Under the hood, they are all isolated, but it's a multi-tenant environment. It was a truly serverless model where you only pay for the execution. The drawback with those was it supported only one workflow. In each Logic app, you can only create a single workflow. And another drawback was there was no virtual network support. And if you had to connect to on-premises system, you were supposed to use an on-prem data gateway to establish the connectivity. And any resources that were shared by the Logic app was shared across different Logic apps running by multiple tenants since it was a multi-tenant environment. Recently, Microsoft, I think it was last year in September, in Ignite, Microsoft has announced this new hosting option known as Standard, which is a single tenant hosting option for a Logic app. It supports multiple stateful and stateless workflows, whereas in consumption, it was a single stateless workflow that was supported. The new standard hosting plan comes with a support for virtual network and private endpoints. The primary reason being it is built on top of Azure Functions Runtime. It essentially runs on an app service plan. So essentially whatever you can do to establish connectivity to an app service to connect it to your private network, you can essentially do the same thing for your Logic apps running in standard hosting option. And the resource sharing, the resources are shared under the standard hosting plan only by the single Logic app that is running inside that standard hosting option. And that standard option can have multiple workflows. So certainly all the workflows that are running in the single Logic app share all those resources. If you have used app services in the past, and if you know what an app service environment is, integration service environment is pretty similar to application service environments. They offer a truly isolated environment, multi-tenant environment, though, but it's completely isolated for you, where you can run your Logic apps. You can directly connect to virtual networks using ISCs. The resources under the ISE are shared by different apps in the same environment, though. Here's a snapshot of how Logic apps are priced under the consumption plan. As I said, consumption plan is the serverless plan. Under this, as you can see, the pricing is per execution. Whenever your Logic app workflow is executed, you are charged for action, standard connector, and enterprise connector. So be aware of that, what type of connector you are using in your Logic app. Based on that, you might be charged for, and depending upon how many times your actions are executed, you are billed accordingly in the consumption plan. Now, as I was saying in the one of the earlier slides, when the new standard hosting option for Logic apps runs on Azure Functions Runtime, it's a new containerized runtime built on top of Azure Functions Runtime, which gives the flexibility to run Logic apps anywhere where the Azure Functions can run. And Azure Functions, as you know, can run on an app service plan. And now recently, Microsoft also announced Azure Arc enabled app services. So you can also run your Logic apps using that feature on any Azure Arc enabled infrastructure now. So this is pretty powerful. It supports multiple workflows in a single Logic app, as I was showing in one of the earlier slides. It simplifies the automated deployment and CI/CD pipelines. I have a slide later to demonstrate the point there, what I'm trying to say here. But under the standard, you can think of that CI/CD pipelines are very simplified compared to the consumption one. I'll show you later how. And since this is this is similar to an app service, you can leverage enterprise features such as private endpoints, VNet integrations, deployment slots, and so on. It also supports integration with GitHub Actions if you are a GitHub user. Here's a snapshot of the pricing, how the standard pricing tier is, a standard hosting option is charged. It is pretty similar to how an app service premium plan is being charged. Azure Functions premium plan is charged based on virtual CPUs and memory. You define the size of the standard hosting plan, and in each of that size, it comes with a dedicated vCPUs and memory, and based on that, you are charged on an hourly basis. Sometimes, as I was saying earlier in one hosting option slide as well, sometimes your logic app needs access to secured resources running inside your virtual networks. You can utilize integration service environments, which is an isolated environment you can create for your multi-tenant logic app service. For example, some Azure Virtual Network uses private endpoint, which you can set up through private link to provide access to Azure PaaS services like Azure Storage and so on. And if your logic app needs access to those virtual networks that have private endpoints, you can create your logic app inside an ISE and connect to those virtual networks. When you create an ISE, it essentially injects and deploys ISE into your Azure Virtual Network. So you can then use this ISE as a location for the logic apps to run. Logic app within ISE comes with its own static IP address, which is separate from the static IP address that is shared by the logic apps in the consumption plan in the multi-tenant service. And one of the benefits you will ask is what benefit we get out of using ISEs. Is you get increased limits on run duration, storage, throughput, HTTP request and response timeouts, and so on. You get increased limits compared to the consumption plan. What you are seeing towards the right is when you are creating logic apps, you will notice different connectors, which are only supported for ISE, comes with that prefix core or ISE. All the supported connectors for ISE have those core and ISE prefixed. Here is how ISE is being priced. It comes with 2 tiers, developer and premium. In developer, there is no scale unit. It just comes with a base unit. You cannot essentially scale it. But in premium, it comes with a base unit as well as a scale unit, which have 2 different pricing tiers. If you are a customer who has been working on B2B scenarios, before you can start building your B2B logic app workflows, you need to use something known as an enterprise integration pack. And before you can start using enterprise integration pack, what essentially you need to do is to create an integration account in Azure with the artifacts that you want to use. What I'm trying to show here on this slide are the high-level steps that you need to get started building the B2B workflows in your logic app. The first step you do is you create an integration account. Once an integration account is created, then you go ahead and add your artifacts. Then you create your logic app, you link it to the integration account, and then you build your logic app with the artifacts and the connectors that I've shown in that I'll show in the next slide. One very good example where you could use enterprise integration pack could be liquid transformation for your JSON and XML files. Logic apps do support basic transformations for your JSON and XML, like composing JSON or parsing JSON. But in more advanced use cases where you need control flows or iterations or variables, you can use liquid open source template language. To use logic app for liquid transformations, you have to follow the process that I'm trying to show here. And here are some of the connectors that are supported by integration account and the enterprise integration pack. Here's a snapshot of the pricing for the integration accounts. It comes with 2 different tiers, basic and standard. As you can see, basic comes with a limited configuration. Standard comes with an improved and increased configuration. All right, enough of the topics that I want to talk about logic apps. Next, I want to talk about how to get started with logic apps. If you want to start developing logic apps, you can, if you are a Visual Studio 2019 user, to create a logic app in Visual Studio 2019, you need to have installed an extension from the extension store called as Azure Logic Apps Tools for Visual Studio 2019. If it is not already installed, you can go to the extensions menu and install it from there. If you are a Visual Studio Code user, you need to install two different extensions. If you are trying to create a logic app under consumption hosting option, you need to use the Azure Logic Apps consumption extension. If you are developing logic apps under standard hosting option, you need to use Azure Logic Apps standard extension. Now, there are two distinct ways. Once you have your development environment ready, you can certainly create logic app in Azure Portal as well without setting up Visual Studio Code or 2019. There are two distinct ways, regardless of how you are trying to develop your logic app. You can design your logic app either in a UI-based designer, or you can design it in a code-based designer. What I'm showing here is a UI-based designer. It gives a very rich GUI where you can create your workflows without writing a single line of code. Alternatively, you can also define your logic app workflow in JSON format, which I will show in the next slide. In a code editor, there is essentially no difference between in the workflows created in UI designer or code designer. Essentially, when you create a logic app workflow in UI designer, it automatically creates the code in the code designer and vice versa. And the entry point for any logic app is a trigger, and that is what you are seeing on the screen here. The very first action is when a new email arrives. That's a trigger that is triggering my logic app. And then what you are seeing is the following actions that I'm performing whenever a new email arrives in my mailbox. What I'm doing is I'm checking if the incoming email has an attachment and it has a phrase in the subject. If yes, then I'm doing certain operations on that attachment. Likewise, as I said, there is an alternate option to design your logic app using a JSON-based code designer. And here is how it looks like. It's a JSON file with similar structure as an ARM template. If you have used ARM template, it's not very different. To start with, the schema attribute, it defines the location for the JSON schema file that describes the workflow definition language version. Then next is actions. Using actions, you can define one or more actions to execute at the workflow runtime. Remember that you can have, the last time I checked, you can have at maximum 250 actions defined inside your logic app. Then the content version defines the version number for your workflow definition, which is 1.0 by default, as far as I remember. You can also define outputs and parameters for your logic apps. The parameters, I believe you can only have up to 50 parameters that you can pass to your logic app for execution. Let me quickly jump on to Azure Portal to show you the experience. So I am inside Azure Portal. I am inside a resource group inside Azure Portal. I'm going to click create a resource and go ahead and type logic app. As you will see, it will give you two different options for logic app. One is simple logic app and one is logic app consumption. Logic app consumption is the consumption hosting option, whereas logic app without anything else is the standard hosting option. They had earlier standard included in the name here, but they have recently removed it. I'll go ahead and pick up the logic app consumption for this demo. I'll click on create. It will ask for a resource group. It will ask a name. I'll give a name to my logic app. I'll choose a location where I would like to run this. Let me choose Central US. If I would like to run it in an ISC, I can go ahead and create an integration service environment beforehand. And if I have that created, I can check that checkbox and include that in the drop down here. Since I don't have an ISC created right now, I'll just uncheck that option. You can also send the running logs into log analytics for your logic app into log analytic workspace. I don't have any log analytic workspace created here, but you can go ahead and create and enable log analytics for your logic app. If you want to provide tags, you can provide tags. So I'll skip them for now and I'll click on create. The very first time your logic app gets created, it opens up with a template where you can choose from how you want like to get started. I'll go ahead and click on go to resource, and this is the template it gets started. It offers me some of the common triggers I can start my logic app workflow with. I can use existing templates. I can certainly create a blank logic app, or I can create logic app built on top of existing templates that Microsoft offers. I'll go ahead and create a blank logic app, and once I go there, it opens up the UI designer for me. And as you will see, it will give me all different types of connectors that I was showing you in my slide deck earlier. It has all the built-in connectors ranging from requests to app services to these are the control workflows. I can go ahead and click control. There is no trigger for that, but first let me go ahead and choose a trigger. Let me create a recurrence trigger if I have it here. If not, I'll go ahead and search here. I'll go ahead and click schedule and choose the recurrence trigger. This is the moment I select that, it creates a basic recurring schedule for me, which says it will run every 3 minutes. I can certainly go and change the frequency ranging from seconds to months, and I can provide appropriate value. I can also go ahead and select the time zone, and I can also provide a custom start time when I want my logic app workflow to get started. I'll leave it as is. I'll go ahead and click new step. So now I have already defined a trigger for my logic app. The next item on my list is to define action. What do I need to do when my logic app gets triggered? So I can certainly go ahead and choose any of the built-in connectors, standard connectors, enterprise connectors, and so on. For example, for this very example, if I would like to, let's say, go ahead and send an email every 3 minutes. So as soon as I select the Office 365 Outlook connector, you will see it gives 2 different tabs here for triggers and actions. Since I'm choosing actions right now, it's not a trigger. That's why it is giving me all the different actions here. But you can see if I would have used Office 365 Outlook connector for a trigger, it offers different types of triggers that can be used to create or to trigger my logic app. Anyways, I can go ahead and choose any of these actions here. For example, if I would like to send an email, I can certainly choose this. The one thing that it needs is since this is a managed connector for Office 365 Outlook, it needs an API connection resource, which is an explicit resource type. I can certainly sign in, and it asks for a credential that I need to use to get my connection set up. And as you can see, it is connected to my demo account that I have here. I can certainly go ahead and hello world, and I can go ahead and choose hello, provide the subject and body. What you are here seeing towards the right side is something very important, which gives us the dynamic content. As of now, I don't have any dynamic content coming in from my previous actions and triggers, but just in case if I have anything coming, let's say if there was a different trigger type which has an input coming with it, I would be able to use it as part of the dynamic content inside my actions. I will show you in next demo how we can do that. But that's pretty much. Once I go ahead and click on save, my logic app is saved. I can go ahead and either wait for it to run every 3 minutes, or I can certainly go ahead and run it from here. Before I do that, I'll go ahead and show you code view. This is exactly what was happening when I was creating my logic app in UI Designer. It was automatically creating code for me as well. So it essentially defines the same thing. This is the schema. This is my action. I haven't sent an email action. Here is my trigger. I have used Recurrence Trigger, which runs every 3 minutes. I can again go and switch to designer, come back to code and make changes, and it will automatically keeps on updating. I can certainly define different parameters here that I can use in my logic app. I can go ahead and choose any existing templates that I might have. I don't have any, so I will leave that. And I can go ahead and look into different connectors that are available for logic apps to be used. I'll go ahead and close this. As you will see in this, since this is a consumption-based logic app, I can go ahead and look into the designer. I can only have a single workflow here. I'll go ahead and since it already executed, let me go ahead and see what happened. So it did execute it. It did send me an email with hello world. And if I have to pull, let me see if I received that email or not. And here's the email that came to me at 6:47 from demo. I'll go ahead and now I don't want to run my application logic app for some time. I can go ahead and disable it so that it suspends any execution of my trigger. If I would like to enable it back again, I can come back here and I can enable it here. And again, just to add the logic app I have created here, in Azure Portal. You can enable, disable, and manage it like any other Azure resource using Azure CLI and Azure PowerShell as well. I wanted to show you a few more demos, which I have already prepared to save some time. So I will go ahead and show you the first one. In this, I have created a recurrence trigger to show you what it does is essentially it looks for all my tweets, not my tweets, but any tweets available which have a hashtag for Omaha Azure. And if it has it, it takes the tweet body and it sends it to me on my email address. So if any one of you will be gracious enough to tweet something and have Omaha Azure as a hashtag, please do so, and I'll receive an email and I will let you know once I receive that email. If you're wondering, it will be something like this since I tweeted the link to the Teams meeting earlier today. So this was the tweet that I tweeted. The meeting starts in an hour, and here's the link to the Teams meeting. And this was the email that was thrown to me. And you can see that here in the run history. You can see my logic app has run these many times, and I can certainly go and look into each of the runs and see how each of my execution run has been. The second example I wanted to showcase was here, where I have tried to use a blob trigger instead of a recurrence trigger. What it essentially does is, before I created logic app, I did created a storage account here. In that storage account, I have created a container called demo2. And what I'm essentially trying to do in the logic app is whenever I upload a new file inside my blob storage, it keeps polling my storage account container, and the moment I upload a new file, it goes ahead and it sends the list of the files that were uploaded. So if I go into storage account and upload a new file, let's say it will upload this file, it will send an email. I'll go back here and see if my logic app was triggered. Oops, I have to enable this. I've disabled it so that it just don't keep running. So I hope it should run. If not, I'll just delete this and upload it again. So that's deleted. I'll go ahead and upload it again, and it's uploading. Hopefully the logic app will execute now since it's enabled. Oops. Demo gods not happy with me. I'll instead just go and run the trigger and see if it executes fine or not. As you will see, it executed and it has sent this body to me saying there was this file that was uploaded, and I did receive the email too. The next demo I wanted to show was HTTP trigger based logic app. Before I show you logic app, what I essentially did was I created a function app. In that function app, I had created an HTTP trigger based function. What it essentially does is I've used the same boilerplate code that it gets created at the time of function creation. It essentially expects a value for the query parameter name. And once I provided it, responds back saying hello with the name. The HTTP trigger function executed successfully. And what essentially I'm doing in my logic app is I have used an HTTP trigger whenever there is an HTTP request, whenever someone makes a post call to my logic app on this URL with this particular body schema, it goes ahead and it triggers my Azure function and it passes the incoming body. If you will see, as I was saying earlier demo, that you can see all the values, dynamic values coming from the previous actions and triggers inside the dynamic content. So as you can see, I have created a parameter here called function key, which has my key, and I have all the values coming in from my first trigger, which is when a HTTP request is received. I'm able to fetch body, headers, queries, path parameters, and name from that. So what essentially I'm doing here is you passing on the body from my trigger to my function app call. And then in my response, I'm capturing the status code from my function call here. This one, which is this action, which is calling my function. And then I'm returning the body. I have Postman already open. So here is my URL that I had here. I'm calling this from Postman. I'm passing name Azure. And if I go ahead and run it, it returns hello Azure. It was executed successfully. If I go back and look into, it was executed at 6:55. So, and I can go ahead and see. One problem you will see here is I have one of the later slides, but you will see I'm passing a secret here to which is the authentication key, the function key to call my function. I might not want to do so that anyone else who has access to this logic app should not be able to see my secret. So one thing you can essentially do is you can go and obfuscate your inputs and outputs. If you will go here inside settings for your action, you can secure your inputs and outputs and click on save or done. Once you will go ahead and click on save, go to Postman and call it once again. And if I go back to the run history again and refresh it, it was executed at 6:56, not this. You will see that that is not exposed anymore. It says content not shown due to security configuration. You can also restrict access to your logic apps from different other IP addresses. If you'll go inside workflow settings, you can control all the inbound IP addresses. You can either, right now it is set to any IP. So my logic app can be called from anywhere in internet, but I can restrict it to other logic apps, or I can provide specific IP address ranges and restricted specific machines from where, or specific IPs from where my logic app can be triggered. Likewise, you can also restrict the access to the logic app content from specific IP address ranges. Once if you have a B2B scenario and you would like to utilize integration account with enterprise integration pack, you can create an enterprise account, which is a different resource type in Azure. Once you have that created, you can go ahead in the workflow settings and configure it here. Last thing I would like to show is if I go back to another resource group and show you how to create logic app in the standard hosting plan. If I click on logic app, click on create, it will ask for a subscription resource group name. Instead of type consumption, I want to choose type as standard. I will give a name LA standard demo. And that's a valid URL. No one else has captured that name. I want to use the workflow, not a Docker container. Region looks good to me. Since it can support stateful workflows, it also creates a storage account for me. If I already have an existing storage account, it will show up here and I can use one of the existing storage accounts. For my standard logic app, I need to choose a plan type, which is similar to an app service plan. Initially, when the logic app standard hosting option was in preview, it was built on top of app service plans, which is not supported anymore. That is why you see app service plan here now. Hopefully this will go away soon. But if you will go and configure the SKU and size for your logic app standard, you will see that it is not different from how an app service plan looks like. So if I go ahead and give it a name, ASP test demo, click on OK, I can go ahead and change size. It is pretty much similar to the experience of how we choose an app service plan for deploying an app service. So what you're seeing is it comes with WS1, WS2, and WS3 workflow standard 1, 2, and 3 sizes, each with the different memory and vCPU configuration. So I'll choose the default one, click on monitoring. I have an option to enable app insights right away, or I can select it later. I'll go ahead and create it right away. I don't want to provide any tags. I'll review my configuration settings and go ahead and click on create. By the time it gets created, I already have standard logic app created earlier, which is like this. If you have worked on app services in the past, you will notice that the experience for standard logic app is pretty similar to what the experience that we get from an app service. You can go ahead and look here into your scale up app service plan blade here, and you can go ahead and scale up your change your app service plan pricing tier from WS1, 2 to 3. You can also scale out the instances if you would like to. If you haven't enabled app insights at the time of the creation of your logic app, you can go ahead and enable it from application insights blade. If you will notice, the only difference between app service and standard logic apps is workflow section here. If you will go and look into workflows, it gives you an option to create multiple workflows, which is different from the consumption-based logic apps, where you could create only a single stateless workflow. But here it gives you an option to create as many workflows as you would like to. If you would like to create a new workflow inside your standard logic app, click on add. It will give you an option to choose stateful or stateless. I'll go ahead and click on stateful and give it a name, stateful 1. And I'll click on create. Once my workflow is created, it has similar development experience as the consumption-based logic apps. It comes with a designer view and a code view. Essentially, these experience remains almost similar. For example, if this is designer, I can go ahead and choose, let's say, schedule. And I can create recurrence trigger. I can go ahead and add an action and choose for Outlook. Pretty much similar to what we have done. not happy with me. Let's say for the example, let's say Azure functions, and I can call an Azure function here. I can pass the connection name here. I can choose the Azure function that I want to call from here. I can give it a name. And get it configured. I'll close this one for now, and I'll go to the existing stateful workflow that I have created. In that, I have used an HTTP trigger, which essentially gives me the similar experience that I had in the consumption-based logic app UI designer. Here is my URL that is created for my stateful logic app that triggers my logic app. I can go ahead and define my settings. Here is the HTTP action where I'm calling my function app. I can see the dynamic content coming from the previous actions. I can go ahead and secure my inputs and outputs, and here is the response. And similarly, I can go ahead and create a stateless workflow. The only difference between stateful and stateless is the past history is not retained for the stateless workflow by default, but if you would like to retain run history for your stateless workflow, head into configuration tab for your standard logic app and add a configuration setting in there for enabling your stateless run history. So just provide a name for workflow stateless operations options and provide a value. With stateless run history, it lets you store history for your stateless workflow. I did run those workflows in earlier before joining this meeting. So that's why if I'll go into stateful, if I'll go into overview tab, you can see the run history. If I click on that, I can see what happened. This was my trigger. It was executed at that time. And then here is how my Azure functions was called. And here is how it was responded. And likewise for my stateful workflow, since I had added that configuration value to store stateless run history, I can see my stateless run history here. So what I've shown so far is how a logic app is created. You can create a logic app in Azure Portal in Visual Studio 2019 in code. I'm sorry, I didn't show you that. Let me show you that as well, the experience in Visual Studio Code. So let's say I'm in Visual Studio 2019. I'll go ahead and click on create a new project. I have already installed Logic Apps tools for Azure for Visual Studio 2019. I'll go ahead and use the project template for Azure Resource Group. I'll give it a name, Logic App Demo. And click on create. It will ask me to choose appropriate template. We can use the same project template to create different other Azure resource type. For this demo, I want to use logic app template. Once I click on create project, it will create the boilerplate code for me. Since I was saying I have already installed the extension, if I go ahead and search for logic app, I have this extension installed. What that does is it essentially lets me go ahead and edit my logic app in a designer within Visual Studio 2019. I can go ahead and choose the subscription resource group. Let's say Visual Studio 2019. I already have a resource group. I'll go ahead and choose that. Once I configure that, it gives me the same experience I've shown you earlier in the Azure Portal. Let me go ahead and choose a template this time. Let's say HTTP request response. I'll go ahead and use this template, and it essentially creates the template for me. I can certainly go ahead and look into open this, save this, and I can see the JSON code for my logic app. As you can see, here's my action of response type. Here is my trigger of request type. I can again go ahead and click on open with logic app. designer, I can certainly edit it. Once I make changes, I already have another example here where I have created similar logic app in Visual Studio 2019. It expects an HTTP trigger to trigger the logic app, then it calls the same function app and returns back the status code and body. Once you are done, you can basically go ahead and deploy to Azure. It will pick up the deployment template, since the consumption-based logic apps essentially are built on top of ARM templates. I will have a slide on that later. I'll show you how that works, but essentially it automatically picked up my ARM template as well as the parameter file. And if I click on deploy, it will go ahead and pick up my changes and deploy it into Azure. Likewise, if I go to Visual Studio Code, I already have extensions installed for Logic App for both consumption and standard. That's why if I go inside Azure section here, you can see all the different standard and consumption logic apps that I have running inside my subscription. I can certainly go ahead and create new here. I can choose the subscription. I can choose the resource group, the location name, and it will automatically create the JSON for me. I can go ahead and update it. And once I'm done, if I'll go ahead and click on save, make changes, it will automatically ask me if I would like to upload it or always upload it. If I go and choose upload or always upload, it will take my changes and deploy it to Azure in the resource group and subscription I have selected. Likewise, you can also see the existing logic apps that are in my environment today. I can go ahead and enable, disable from Azure Portal. I can go ahead and edit in the editor. I can go ahead and view it in Designer and see what's going on in my logic app. Pretty neat experience. So coming back to states of a logic app, whenever you have a logic app, whenever your logic app workflow gets executed, every time a new instance of your workflow is executed, it could result in one of the following states. It could be succeeded whenever the logic app or run is successful. It could be in a running state when the execution is in progress. It could be in a failed state when the execution has failed. It could be in a skipped state whenever the logic app run or trigger has been skipped, and sometimes it might be timed out when the execution takes too much of time and the execution gets timed out. Whenever you are creating an Azure service, not just Azure logic apps, but any Azure service, access control is always an important consideration. It always pays off to consider who can access your resources in Azure and who can do what. If you're not aware of, for Azure Logic Apps, there are two different roles that are built in to control access control in your on your Logic Apps, namely Logic App Contributor and Logic App Operator. Logic App Contributor role lets you manage Logic Apps, but you cannot give access to others. Logic App Operator lets you read, enable, and disable Logic Apps, but you cannot modify the workflow, and certainly you cannot get permissions to others. Now, there are certain situations where you would like to lock out your resources in Azure so that people cannot edit them or delete them. For that purpose, you can use Azure Resource Locks, and Azure Resource Locks are also supported on the Azure Logic Apps resource type as well, so that you can avoid accidental modification or deletion. And this is, I've already shown how you can obfuscate your run history using secure inputs and outputs option. I did show you how you can control access to your logic app through specific IP address rules. I was mentioning when I was showing you Visual Studio 2019, talking about the multi-tenant logic app, the consumption-based logic apps essentially uses ARM templates, the JSON format as their deployment model as well as design mechanism. You can version control your ARM templates for your logic app in a repo, and you can deploy it through your Azure pipelines. If you will head out to the link I have provided from GitHub, they have published different samples that you can use, probably refer to when you are setting up CI/CD pipeline for your consumption multi-tenant logic apps. If you are an Azure DevOps user, you can also use the built-in task that comes in Azure pipelines for deploying ARM templates to deploy your Azure Logic Apps. I have provided a link to a blog post I posted sometime back to deploy a Logic App using Azure DevOps YAML pipeline. If you are trying to do similar thing, you can probably check out my blog post. If you remember in one of the earlier slides, I was mentioning that the new standard single tenant hosting option has simplified the overall CI/CD experience for Logic Apps. The primary reason for that is, if you will notice, in the consumption based, there can be only a single workflow, and it creates a single code JSON for you, which is merged inside ARM template, and you have single JSON template that you have to use for your deployment as well as for designing your Logic App. That is not true anymore for the standard single tenant Logic Apps. You can essentially segregate your Logic App workflows from the infrastructure definition, which is your ARM template. The advantage you get out of it is that then you can manage your Logic App workflows in separate files and publish changes through your CI/CD pipelines. And then you can also define your Logic App standard infrastructure definition as part of the ARM template and deploy new Logic Apps through infrastructure as code pipelines. I did touch upon this experience. When you are creating a Logic App, you can export your Logic App runtime logs to Log Analytic Workspace. You have to have a Log Analytic Workspace created up front. You can certainly collect diagnostic data for Logic Apps by enabling diagnostic settings. This is not different from any other resource type. You can enable diagnostic settings for most of the Azure resource types, and you can send the diagnostic data to either Log Analytics. You can export it to an event hub, stream it to an event hub so that it can be exported to a third-party system, or you can also archive the diagnostic logs into a storage account by setting the appropriate settings here. I did show you can enable application insights for the single tenant Logic Apps by going inside application insights blade. I did cover most of the things, so I will just skip the demo for this piece. The last piece I want to touch today is the business continuity and disaster recovery options for Logic App. When you create Logic Apps, you can follow different patterns to implement to handle business continuity scenarios. One of the patterns that I'm showing here is you have two different apps. We are following active-passive pattern here. You use a single ARM template to deploy both the Logic Apps. One is primary location, one is secondary location. One could be East US, second could be West US. And what essentially happens is once you have active and passive, you can keep your active Logic App in enabled state, and you can have your passive Logic App in disabled state. And whenever your active Logic App goes down, you can enable your passive Logic App to process your workflow. You can also implement an active-active pattern using Logic Apps. You can have two different Logic Apps, one in your primary location, one in your secondary location, both in active state, both in enabled state. And then on top of that, you can essentially utilize an Azure APIM or an Azure Load Balancer or an Azure Service Bus to distribute the load between the two different instances of the Logic App. Basically, using Service Bus, you can implement a competing message consumers or processors pattern. I have provided a link down below there. If you are interested in implementing this pattern, you can check it out, the documentation up there. This is what I was talking earlier about the active passive, where once the active goes down, you can enable the passive one. You can certainly mix and match two different options, active and passive ones. What you are seeing here is you have two different Logic Apps here, one for checking email, one for checking message. For the checking email, you have using active passive pattern. Whereas for check message, you are using active-active pattern, which is implementing competing consumer pattern. So quick snapshots of the benefits that you get out of Logic Apps. It lets you build workflows without writing a single line of code. Pretty easy to get started with implementing your workflows. It offers first-class support for enterprise integration in B2B scenarios through a handful of connectors that you can include in your workflows. You can certainly write it once and it gets stored in as JSON, and you can reuse that as often as you would like. It's quite extensible because it's part of Azure ecosystem. It comes with more than 400 plus built-in and managed connectors, and you can integrate your Logic Apps with different types of services, not specific just to Azure, but even outside of Azure as well. Lastly, it also comes with a consumption plan where you only pay for what you use. If anyone of you have used Power Automate, you would have noticed lots of similarities between Azure Logic Apps and Power Automate, and which is not incorrect. There are similarities between Azure Logic Apps and Power Automate, but there are some differences. Azure Logic Apps is part of Azure ecosystem, whereas Power Automate is part of Power Platform. Azure Logic Apps is targeted for more advanced users, IT professionals, and developers, whereas Power Automate is targeted for power users and citizen developers. And using Azure Logic Apps, as I was shown earlier, it supports advanced workflows and integration workflows like integration accounts, liquid connectors, business-to-business connectivity, and so on. Those scenarios are not possible using Power Automate. Power Automate just comes with a UI-based designer. There is no code-based designer for Power Automate, unlike Logic App. And lastly, Power Automate is a SaaS solution, so you can do everything on browser. There is nothing really to do for CI/CD. But Azure Logic App, since it's part of Azure ecosystem, it's part of ARM template. You can implement continuous integration and delivery for your Logic Apps. With that, I don't see any questions on the chat window. So if there is any questions, feel free to unmute yourself and ask me any questions you might have. Other than, if no other questions, you can reach out to me offline. If you come up with anything later, I will be more than happy to answer it offline. You can reach out to me on Twitter or LinkedIn, or you can also email me if you have any specific use case or question you might like me to answer. If not, thank you so much for joining today.